Okay, hello everyone, and welcome to our YEA Big weekly physics lectures. So our problem for this week comes from the F equals MA exam, and it's a ping pong ball with mass M, shown in this figure, has an initial horizontal velocity v and angular velocity omega, and it comes into contact with the ground, and there's friction, so the velocity and angular velocity of the ball changes, and it asks what is the critical velocity VC such that the ping pong ball will stop and remain stopped. And also, it's worth noting, I probably should have put this in the problem, so my bad, but the answer should be given in terms of omega and r. R and M, these constants. Okay, so now, all right, so the first thing we have to do is figure out what does it mean by the ping pong ball stops and remains stopped. Well, when the ping pong ball stops, that means it's at rest. So that means V, the velocity of the center of mass, has to be zero, of course. But to remain stopped, that means that at the exact same time, omega also has to be zero. Because if V is zero and omega isn't, and since the ping pong ball is spinning, that will eventually cause the ping pong ball to move, and then V will be non-zero and the ping pong ball will start moving. So then that means that at some time t, we need to have both Vt and equals zero, and omega t is also equal to zero. Okay, so to find this, that's pretty easy. We just know that Vt is going to be equal to V minus At, where A is the acceleration. And this acceleration comes from the frictional force, of course, because if we look at it, there's gravity, there's a normal force, but those only like go up and down, so they don't affect the velocity of the ball. And so then the only other force is this friction force for pushing back on it, which gives it an accel, which is F, of course. And yeah, that's the only this force remains constant throughout the entire process. So it's going to have a constant acceleration A. So now we have V minus AT is equal to zero. Similarly, our expression for omega t is going to be omega minus alpha t, and it's also equal to zero. So A is equal to just this frictional force F over M. That's pretty easy. Alpha is a bit more complicated, but still pretty simple if you've learned physics before. Alpha is just equal to the torque over the moment of inertia I. Torque is, of course, equal to F times R. And the moment of inertia of a hollow sphere is 2/3 mr squared. So this is equal to 3F over 2mr. Okay, so now it's pretty easy to solve these two equations. We get that V, and this is the critical velocity, of course, Vc is equal to F over mt, and omega is equal to 3F over 2mr times t. So now we can see that it's really easy to see Vc in terms of r and omega. We just get Vc over omega allows us to cancel out m and f and t. Since we don't know f and t, so it's nice to cancel it out. Or so this is just 2r over 3. So then Vc is just equal to 2 omega r over 3. So that's the answer for the critical velocity such that the ping pong ball will stop and remain stopped. So overall, this week was a pretty easy problem then, pretty simple. So that's it. Thank you for listening.